Today's talk is going to focus on the integrated control of mealybugs. We're going to start off with a brief background and a catch-up on mealybug, what they are and which species are of most importance. Mealybugs produce a wax filament that covers both the bodies of the nymphs as well as the adult females, hence the common name of mealybug. Mealybugs belong to the family of Pseudococcidae, which are small, soft-bodied, phloem-sucking insects where they make use of their piercing sucking mouthparts to feed on the plant sap. Worldwide, over 2,000 species have been identified and described. However, in South Africa, only 20 species are considered as economic important pests in agriculture. Amongst these 20, in this table, I've listed the most important ones, which contain longtail, citrus obscure, vine, citrophilus, stripe, karoo thorn, and oleander mealybug. As I mentioned, these are widely considered to be the most important when it comes to economic damage, purely because of the wide host range and the economic impact that their infestations can cause. The general life cycle of mealybug starts at the egg phase for the female side. This is then followed by 3 subsequent nymphal instars. After the last molt of the 3rd instar, an adult female emerges. Now, this is quite different for the male side. They have 2 nymphal instars followed by a pre-pupa in a cocoon, and then a pupa in a cocoon, and then the adult male emerges. Adult males are considerably smaller than the adult female. They also look considerably different, with developed antennae, legs, 1 pair of wings, and are characterized by these anal filaments that are long and white. From egg to egg, in terms of life cycle, it takes them between 4 and 5 weeks during hot summer times, and this can be extended for several months or to several months during the colder periods of the year. Females are able to lay between 300 and 600 eggs, depending on the season and also depending on the specific species. Just important to note that this is the general life cycle. This depicts the general life cycle where eggs are laid in egg sacs, waxy egg sacs. This is, however, not the case for long-tailed mealybug and pineapple mealybug, where the females deposit already hatched first instar nymphs. Damage caused by mealybug can be divided into 2 distinct groups, namely direct damage and indirect damage. When we talk about direct damage, we are talking about the damage that is directly caused due to the feeding of mealybug on our crop. Severe infestations can lead to fruit drop, leaf drop, malformation in the form of discolored welts on the fruit or shoulders, and then a general lack of vigor and stunted growth is visible as a direct cause by mealybug feeding. Then when it comes to the indirect damage, this is associated with the sooty mold growth that is largely associated with mealybug infestations. As I mentioned, they feed on the plant sap. The plant sap contains high concentrations of sugars, but very low concentrations of protein. So for mealybug to take in adequate amounts of protein, they need to take in large amounts of this high sugary sap, and the excess sugars are then excreted in the form of honeydew. Sooty mold then grows on these copious amounts of honeydew. This then covers the leaves in a sooty mold layer, which then reduces the photosynthetic capabilities of the plant. These sooty mold can also then discolor the fruit and stain the fruit. In terms of Viruses, they are also significant vectors of certain viruses and diseases, such as in the case of the vine mealybug, which is the most prominent vector of the grapevine leaf roll virus. Additionally, they are also considered as phytosanitary pests in various export markets. Therefore, the economic impact that they can have in terms of phytosanitary considerations can far outweigh their conventional pest status. What we do as realIPM is literally in the name, is integrated pest management. And the best way to depict this is probably in the form of a house, where integrated pest management, or IPM, forms the roof of this house. Unfortunately, this roof is just as stable and strong as the pillars that it is built on. These pillars consist of various control strategies that are effectively integrated to give the farmer the best result at the end of the day. These pillars consist of biological control, chemical control, cultural control, as well as host plant genetics. But very important, scouting and monitoring form the basis and the foundation of any well-functioning IPM program. Let's start off with beneficial insects, which form part of the biological control pillar. At realIPM, we have 5 beneficial insects at our disposal to combat mealybug infestations, with the first 2 in this table being Anagyrus vladimiri and Coccidoxinoides permanutus. These are both parasitoids. Parasitoid wasps lay their eggs inside their mealybug hosts. The larval wasp then goes through seminal instars inside the mealybug host, feeding on the internal organs, eventually turning it into a mealybug mummy, as it's commonly known in the industry, as you can see here, where a wasp has freshly emerged from its cadaver, from the mealybug cadaver or the mealybug mummy. Both of these are parasitoids, endoparasitoids. So for Anagyrus, it effectively targets vine, obscure, grape, citrus, and oleander mealybug. It is a wasp that effectively targets the 3rd instar of the female life cycle, as well as the adult female. When it comes to permanutus, that you can see down here, they effectively target both vine and citrus mealybug. But because it is a much smaller individual, a much smaller wasp, they are only able to parasitize the 1st instar nymph, the 2nd instar nymph, in some cases also the 3rd instar nymph, but they prefer to parasitize the 1st instar nymph. As you can see, I've listed here on which species they are effective against. So it is absolutely important that we correctly identify the specific mealybug species that we are working with before deciding on which parasitoid or beneficial insect to release. Then the last 3, or the bottom 3 here, are predators. They actively hunt and feed on mealybug as their food source. The first one being Cryptolemus montazeri. It is a generalist mealybug predator. Here it is down here, a depiction of it. It is also commonly known as the mealybug destroyer in the industry. It is as a generalist mealybug predator. It's able to feed on a wide variety of mealybug species, and it is also able then to target all the life stages in the mealybug life cycle. Neophis camberovi is also a generalist mealybug predator, but it is a much smaller beetle, and is therefore only able to feed on the eggs, as well as the 1st instar nymphs, and to some extent on the 2nd instar nymphs. Chrysoperla carnea, or more commonly known as the green lacewing, is a generalist predator, meaning not just feeding on mealybug, but then also feeding on a wide variety of other pests, such as thrips, spider mites, aphids, and whitefly, to name but a few. Lacewing is literally the lion of the insect world, and it will devour anything it can overpower. In these photos at the bottom here, you can see lacewing with the big jaws that they use for feeding, through which they inject enzymes that help dissolve their prey's internal organs. You can see that they are also known as trash carriers. They use the cadavers of the insects that they prey on and pack them on their backs as a form of camouflage, not just to prevent predation on them, but also as a way to deceive ants that are farming with mealybug, so that they can effectively also prey on mealybug. Then we come to our biopesticides, which also form part of the biological control pillar. We use our biopesticides effectively to support our beneficial insects. Very important here is that we use the ones that are selective, in which they see as host insects. This whole cycle or infection process starts with the spore attaching to the cuticle of the insect. The spore then germinates and starts producing opressoria. Penetration of the cuticle is eventually achieved through a combination of mechanical pressure by the opressoria, as well as enzymes that degrade the cuticle of the insect. Eventually, when the host immune response is overcome, hyphal bodies are produced, and the insect host eventually dies as a combination of internal organ damage, nutrient depletion, and poisoning due to the secondary metabolites that are produced by the EPF. The entomopathogenic fungus that we prefer to use for mealybug control as realIPM is real Metarhizium 69. Now, real Metarhizium 69 contains the spores of the species Metarhizium anisoplia, strain Isipe 69. As you can see, it's registered for mealybug control on avos, berries, citrus, pome fruit, stone fruit, as well as tree nuts. And at the end of this cycle of this infection process, if the conditions are conducive, you'll get these spore-producing conidiophores that grow out of the cadaver. And in this case, you can see what it looks like when mealybug is infested with Med69 with this green, clumpy, spore-producing conidiophore. This is actually an example of a mealybug, and you can see it's completely overgrown. We did several efficacy trials of Metarhizium on mealybug. The ones that I'm going to show you today are on citrus and grapevine. In the Kirkwood, Clanwilliam area, we did citrus, and in Groblersdal and Paul, we did the grapevine trials. On the y-axis, we have the corrected level of effectiveness as a percentage value, and on the right, you can see the key, where the green columns are real Med69 at the rate of 200 milliliters per hectare, the middle column being real Med69 at a rate of 400 milliliters per hectare, and then the standard registered chemical product, in this case, buprofezin, at a rate of 60 ml per 100 liters. Throughout the Kirkwood trial, we saw a corrected level of effectiveness ranging between 80 and 100% for both the 200 milliliter per hectare dosage rate as well as the 400 milliliter per hectare dosage rate, and there was no significant difference between the results obtained for the Metarhizium treatment versus that of the standard registered chemical product. For the Clanwilliam citrus trial, unfortunately, in November, no mealybugs were present or were scouted, and we saw that in February and in March, the levels of effectiveness ranged between 70 and 75% in Clanwilliam on citrus, also walking hand in hand and going hand in hand and not differing significantly from buprofezin. On grapevine, similar, the green columns are Med69 at a 200 ml rate, The darker column in the middle is at 400 mils, with the blue being a combination of Mospilan and Confidor. And similar results were obtained where the effectiveness percentage ranged between 80 and 90% in both Groblersdal and Paarl, once again, not differing significantly from the standard registered plant protection product. When it comes to cultural control, it is probably the pillar that is most often overlooked. It can play a big part in suppressing pest populations. Cultural control literally we aim to make the environment unfavorable for pests to develop and to become an economic problem. For mealybug, cover crops that produce flowers are a very good option, as they can become a crucial food source for natural enemies such as our parasitoids. Secondly, optimal irrigation and fertilization leads to physiologically healthy plants that can more easily resist insect or pest damage and can also recover faster from that. It is widely noted that excess nitrogen fertilizer leads to vegetative growth, and we know that mealybug prefer to feed on this new flush.
Reynardt, sorry to interrupt. We have 2 minutes to go. I'm not too sure if there's quite a bit more to go, but if there is, then can I suggest that when the time ends, everyone just logs on with the same link again, and we should be able to continue if that's okay with everybody.
Okay. Perfect. Okay. Selective pruning is also can play a big part. We know that mealybug climb into crevices that are difficult to get to, and by pruning selectively, we can easier control them by getting contact with our sprays. Ant control plays a really big role. As I said, they produce copious amounts of honeydew, and then ants come and they literally farm and protect mealybug for this honeydew. So by effectively skirting our trees and then also doing effective ant control measures, we can increase the capability of our beneficial insects then to do their job and feed and parasitize on mealybug. This is an example of one of my colleagues where they released mealybug predators and parasitoids, and after 2 weeks we found that most of the orchard were clean, except for the specific hotspot where ants literally farmed and protected the mealybug. We did no additional sprays in terms of mealybug control. All they did is they applied a proper ant control measure, and they, after 2 to 3 weeks, this is what we saw, that the mealybug predators and parasitoids did the job that we deployed them to do. How we see chemical plant protection products, as I think most of you have seen these optical illusions. When looking from the one side, you see a certain image, then when looking from another, you see something completely different. As in this picture, we're looking from the left, you see a duck, and looking from the right, you see a rabbit. As a biological producing and selling company, you probably think that we are completely against chemical pesticides. This is, however, not the case. Just as this picture, we just look from a completely different angle. Most people would be able to know the names, the commercial name, the active ingredient, maybe even the group. But as realIPM, we look deeper into the chemical plant protection products that we use and employ. And we specifically look at the efficacy or the knockdown that we get on our beneficial predators and parasitoids, as well as the residual period that we get on from them. So at realIPM, we look to use selective insecticides that have little to no non-target effects on our beneficial insects, with the shortest possible residual effect or residual period. This is, however, not a one-size-fits-all scenario. We do make use of historical pest pressure as well as monitoring and scouting, which also allows for flexibility during the season. The take-home message then from this talk is that true IPM is the future of South African farming. As real IPM, we make use of a three-pronged approach for pest control, which rely on beneficials, but we need to be able to give our beneficials a fighting chance to do their job by supporting them with selective biopesticides as well as selective chemistry that have a short residual period. And when talking about and referring to beneficial insects, I'm not just referring to the ones that you buy in your release, I'm also referring to the ones that naturally occur in your orchard, that do the job for you for free, even on holidays. Thank you.